Thank you very much for allowing me to make this presentation on the installation of our acoustic pyrometer for combined cycle power plants. This slide will show you some images of the installations of the PCU, which is a processing unit, and also the sensors. The first image or first picture is basically how it looks, the complete two components. Then later we will see one sensor, which we will go into detail further on how it is installed. And then you'll see the PCU where it's got to be mounted within 600 feet of the HRSG. SCI Incorporated will provide you as a potential customer a conceptual project drawing. Once you identify where the system will be installed, we can add the customer name and the city and the state where it will be installed. Slide number 2 talks about the table of contents. Item 1, cover page. Item number 2, table of contents. Item 3 and 4 are the locations where you place the transceiver. Item number 5, signal distribution. Item number 6, pneumatic distribution. 7 is the block diagram. 8 is the waveguide specifications. Item number 9 is the transceiver dimensions. Item number 10 is the typical installation on a HRSG. 11 is the pneumatic detail installation. Item number 12 is enclosure installation details. 13 is amplifier wiring diagram. 14 is the PCU enclosure installation details. 15 is PCU enclosure specifications. 16 is PCU board connection layout. 17 is the preamplifier interconnect diagram. And 18, which is very important, it's the bill of materials. This slide will inform you about the sensor location and the map position. Take note that in this case, we are recommending a total of 8 sensors, 3 on each sidewall plus 2 on the penthouse, which will give you 21 gas temperature trajectory. If your duct burner is operating with no errors or uniform combustion, you will see a map in your control room that illustrates a complete isothermal uniform map. Take note that the placement of the sensors are on the red line that we're showing you. And this red line is basically a minimum of 3 feet in front of the first process tubes. Take note on the right side that you can see the placement of 3 sensors on the left, 3 sensors on the right wall, and 2 on the penthouse. These are transceivers. Some may act as a transmitter and some may act as a receiver. We're now showing you a picture of a HRSG so that you can understand where the placement will be with reference to the stairs that you have in your facility. In this slide, you see an isothermal map that is showing higher than usual temperatures on the lower part of the isothermal map. In this case, you can use the other features of TMS 2000 to see the temperature differences from the normal combustion parameters to the one that's showing the hotspot, which is shown in yellow. Take note also that on the right side, you have a side view of the placement of the sensors. In this case, we recommend that the lowest sensors be placed 3 feet above the floor of the HRSG. Slide number 5 is simply the cabling guide. We use cables similar or equivalent to Belden. The signal cable is primarily minimum of 4 pairs. Ideally, it would be 6 pairs of 18 to 22 gauge cables. Then we have the solenoid cable, which is basically just a very simple 1 pair 18 gauge. We normally run all these cables on cable trays all the way to the PCU, which can be mounted up to 600 feet. There is no problem because the Belden or its equivalent cable is shielded, so we have no problem with high voltage lines. This slide talks about the service air requirement, which is between 60 to 100 psi. It is intermittent. From the air compressors, we receive a 2-inch header line, and as soon as you get within 3 to 6 feet from the sensor, we place a T and we use a pipe which is 1 inch in diameter with its own manual shutoff. Here we install the air hose which we supply, which sometimes is between 3 feet to 6 feet for an adequate installation. Take note that the only moving part is the air solenoid valve. They last between 4 to 8 years. Also, depending as to the installation, we can also remote mount the valves up to 20 feet from the actual stainless steel sensor. Here we're showing you where you install the PCU at the field and also the mapping computer in the control room. Take note that the maximum distance between the sensors to the PCU is 600 feet. Between the PCU and the control room, we send information up to 1,000 feet using RS-422. In the case that you do require more length, then we can go into fiber optics. Nowadays, with the smartphones and big screens, it is very easy to supply this information from the control room computer. Here is the dimensions of the waveguide. The material that we're using right now is stainless steel 3/16, and there's basically no maintenance in this case, since once the air is used to generate the noise, it also cleans interior of the waveguide and also cools the system down. So this is basically the waveguide dimensions. It weighs about 25-30 pounds. This slide will show you valve placement, venturi, shutoff, and the microphone. Lightly colored in blue is the only moving part, which is the air solenoid that receives air, service air. This is connected to the manual shutoff. Then it's connected to the venturi, which is basically a converging, diverging nozzle, 4/10 of an inch opening to increase the decibels of sound being generated, which is 126 dB, and reduces the airflow tremendously. Air, as it enters the waveguide, is deflected 90 degrees, and then as the sound progresses toward the microphone, when it is being used as a transmitter, it sets T0 for the signal processing algorithm to calculate the temperature, the gas temperature. Slide number 10 is the complete assembly on the HRSG wall. Take note, on the left side, you can see the preamplifier box, which can be mounted 20 feet away from the sensor. Lightly in blue is the service air solenoid valve, which can also be remotely mounted 20 feet away. You have the manual shutoff, and then you have the venturi. Note also that you have the microphone, and on the right of the microphone, you can see the actual transition cone and the wall of the furnace. You have aspirating air, which is the valve at 45 degrees in case you want to remove during operation the complete assembly. Slide number 11 is the details of the air connection for the sensor. In this case, in the blue rectangle, you can see that we have a 2-inch header on the right side. You have a T You have a manual valve, you have an air pressure gauge and a flexible hose connecting to the solenoid valve. Then you have your manual shutoff, and then you have your microphone, you have your aspiration air, and then you have your cone. This slide, number 12, is simply the mounting bracket for the preamplifier. The preamplifier is an MA4 fiberglass enclosure. Inside is basically the preamplifier box that receives all the signals from the PCU. Slide number 13 is the wiring preamplifying. Take note we use -12, +12 volts VD, and 120 volt VAC. This is where the signal cable, which is between 4 to 6 pair, this is where it is terminated. Top left, you will see the microphone where we use 3 cables. It's basically white, black, and a shield. On the bottom left, you have the solenoid valve, which uses 3 cables, hot, neutral, and ground. And on the right side of the preamplifier, you have basically shield, -low, +low, -high, etc. And this is where the 18 gauge to 22 gauge cable is terminated. Take note that the shield is not connected at the preamplifier box. Slide 14 is a PCU mounting bracket. This is where the customer supplies us 120 volt VAC with a good ground. All the electricity that is required by the sensors and the solenoid valves are controlled by the PCU. The PCU size is approximately 24 inches wide, about 32 inches tall, and in depth only about 12 inches. The complete PCU weighs less than 45 pounds. Slide 16 is the wiring inside the PCU. Take note that in the red rectangle is where we connect the receiver cabling from the sensors, the preamplifier sensors. The rectangle in blue shows where we connect the transmit side. On the far right, you can see a yellowish rectangle. That is where you mount or you connect your solenoid valves. On the bottom right, you see orange, and this is where you have AC in. And on the bottom left, you see some rectangle, which is green, where you connect the RS422. The complete wiring details refers to the connections between the preamplifier box and the transmission and receiver sections of the PCU board. Note on the left top is the microphone. On the center, you can see the solenoid valve. On the right side, you can see where the RX, which is basically the receiver part of the CIG board, and on the right side is the transmit. Slide 18 is the bill of materials. Basically, we will supply you the PCU, all the sensors, and the mapping computer. In some case, the customers request for a large monitor. We also will supply you the communication cables, the solenoid control cable, as well as the communication cable for the RS422. Manual ball valves, pressure gauges, tees for the pressure gauge mounting, bushings, flexible hoses. We supply all that. Thank you very much for allowing me to make this presentation. If you have any questions with reference to the installation, feel free to call me at any time. If you require further assistance in the Southeast, please contact Stephen Mattis from Entech Products Corporation. Thank you very much.